Hey guys, these are our notes from Wednesday about taking inverses when you see an exponent. So this is Unit 4A. Reminder, just as soon as you're done with your notes, put them into your digital notebook. Just delete the photo. These notes are due the day of your test. Okay, so to start us off, you need to put your title up at the top of your paper. Want to be nice and organized. You don't have to write down the essential question. I forgot to put it on our little slides presentation, but these are the questions we want to answer. What will the inverse of an equation with an exponent contain? What are the steps to finding an inverse? So finding the inverse, I'm going to answer kind of that first question. What will the inverse of an equation with an exponent contain? So if you see an exponent, you're going to have to use a root to cancel it out. So the inverse of an exponent is a root, so all of your answers will have a radical in them. So finding the inverse, we're just going to say to cancel an exponent, you use a root. So the inverse will contain a radical. So if you see an exponent, if you see a power of 2, then your inverse is going to have a square root. If you see a power of 3, you're going to have a cube root. If you see a power of 5, you're going to have a fifth root. So whatever power you see, you're going to have a radical, and the root will be whatever the index of the root will be whatever the exponent was. So we're going to write down some steps now. The first step is to, just like what we did yesterday, you're going to replace f of x with y. Then you're going to switch x and y. So finding the inverse, we're doing the reverse. Step 3, you're going to isolate your y to the power of something. There might be parentheses around it. There might not be parentheses, but if there's something like multiplied on the y or added to the y, it would be in the parentheses. If there's no parentheses, you just get the y to the n by itself. Step 4 is you're going to take the nth root, whatever the exponent is. If n is even, like a square root, a fourth root, an eighth root, you're going to have to put a plus or minus in front of the radical. And I'll show you guys graphically why that is. Step 5 is to go ahead and solve for y if necessary. Like if there was something in the parentheses with it. And lastly, step 6 is just to go back to function notation. So we replace y with that f inverse. Looks like f to the power of -1, but we read it out loud, we say f inverse. Or if the original function was g, we'd say g inverse. If the original function was h, we'd say h inverse. Okay, now let's go do some examples. So our first example is f of x equals 3x squared plus 15. So if there was no exponent here, it would have been just like yesterday. We would have done the same thing, but this time we have a square. So if you see an exponent, then your answer is going to have a radical. So we're going to follow these steps right here. So step 1 is to replace f of x with the letter y. So I'm just going to cross it off and put the letter y. Step 2, we switch x and y. So now it becomes x equals 3y squared plus 15. So notice how there's not any parentheses, so I can go ahead and when I isolate y to the power of n, there are no parentheses, that's okay. So I'm just going to go ahead and, get this piece right here by itself. So same steps as what you guys would have done yesterday. In reverse, instead of multiply by 3, add 15, we subtract 15. And to get rid of the 3, we divide everything by 3. Here's kind of how I decide if I'm going to do one big fraction or if I'm going to split it up into 2 separate fractions. If one of these numbers right here can be evenly divided by 3, the x or the 15 can be evenly divided, then I do 2 separate fractions. If it wasn't, either one of them was easily dividable, then you could do a big fraction like how this one looks. So either way. So when I divide, I'm going to put it in like slope-intercept form. There's technically a 1 in front of this x, so it'd be 1/3 x minus 15 divided by 3 is 5 equals y squared. So there was no parentheses, but we got our y squared by itself. We isolated it. Now you have to take the nth root on both sides. If n is even, you have to put a plus or minus in front. So it has a square. That's an even number. So I'm going to take just a square root. But what that means is I have to put a plus or minus in front of it. What happens when you square a square root is they cancel each other out. So now y is officially by itself. So I can replace y with f inverse of x. And there's nothing I can simplify over here. It's just this radical. And I'm going to show you why we need that plus or minus in front of it for our answer. So notice how the original problem had a power of 2. And this one has a square root. So the inverses, if you see a power, all of our answers we're going to have a radical in them. Let me show you why we need that plus or minus. So here's Desmos. Here's the graph of our original function. This is 3x squared plus 15. Here's the line y equals x. This line right here is a, let me do a dash line. This line right here is the line that our graph will be reflected over. So if I type in if I forgot the plus or minus and I just did the square root of 1/3 x, was it minus 5? I think so. Oops, what happened there? Minus 5, okay. Does it make a whole parabola? Because this should be reflected over to the other side. So if I only did the plus side, I only get part of the parabola. I also have to have that minus sign in order to get the whole entire parabola. See how now this green and purple together make that whole parabola. So if it's an even number, you have to do that plus or minus in front. If it's an odd number, you don't have to worry about it. But if it's an even number, to get both sides, you have to have that plus or minus in front. All right, 3 more examples. So my next one, follow those same exact steps. So g of x equals x cubed plus 4 divided by 9. So first off, I replace this with y, and then I'm going to switch x and y. All right, so notice how this one has a fraction. That's the first thing that I'm going to go ahead and get rid of. So in order to undo dividing by something, the opposite of that would be multiplying. So I'm going to multiply both sides by 9, so it will cancel. Then I get 9x equals y cubed plus 4. And then I'm going to just keep trying to isolate. Step 3 was to isolate your y to the power of something. So I'm going to subtract 4 on both sides. So I get 9x minus 4 equals y cubed. And then the way that you cancel out a power of 3 is you have to use a cube root. So to do a cube root, you just put a little 3 outside of your radical. And what happens is that they cancel each other out. So they're no longer there. And then now y is officially by itself. There's nothing else attached to it. So then I can go ahead and change that to f inverse of x is the cube root. Since the cube root is an odd number, I don't have to worry about that plus or minus. So it's just 9x, the cube root of 9x minus 4. That's the reverse, that's the inverse of the original problem. Oops, I shouldn't have written f of x. I should have written g of x. This is George, not Frank. So g of x. All right, so this is one picture you guys are going to take for your notes, and then we're going to do example 3 and 4, so you can either take a picture now, you can draw a line to remind yourself that this is one picture, you can flip your paper over, whatever you need to do. All right, so the next two examples, if you notice, these ones have parentheses. So they're still going to be solved similarly, just we're gonna have stuff to do after the radical. So first step is still to replace your f of x. This one's h of x, but we replace the letter y, and then we switch x and y. So notice how this one has parentheses. So when I go to isolate the parentheses, there's nothing outside the parentheses, there's nothing in front, nothing at the end. So I'm going to jump straight to taking the nth root. So since this is a square, then I'm going to take a square root on both sides. Have to remember to put a plus or minus in front. But what goes ahead and it cancels each other out, the square and the square root. So I just have plus or minus the square root of x equals 2y minus 3. So now, since there was those parentheses, there was things inside the parentheses with the y. So this is when we need that step 5 of solving for y if necessary. So just like we would yesterday, we're going to go ahead and do the reverse. I'm going to add 3 to both sides. You could technically put the square root part first. You do plus or minus the square root of x plus 3, but sometimes it gets confusing if you write it like this. For people to know if the 3 is under the radical, like if you draw your radical too long. So I'm just going to go ahead and put it in front. It could go after though as well. And then lastly, I'm going to go ahead and get rid of that 2. So I'm going to divide both sides by 2. When I look at this, neither of these things can be evenly divided by 2. So I'm actually just going to leave it as one big fraction for this problem. So they cancel. So y is officially by itself, so I can go back to function notation. So the original problem was named h, so it's Harry. So h of x equals, and then I just put 3 plus or minus the square root of x over 2. So you only do plus or minus if your original power is an even number. So that's why I need that plus or minus. I could have simplified it to also be like 3 over 2 plus or minus square root of x over 2. That's also fine, but I'm just going to leave it as one big fraction since neither of them could be evenly divided. All right, one more. All right, number 4 is another f of x. So step 1 is I'm going to go ahead and replace f of x with the letter y. We have 2 parentheses x minus 4 squared plus 1. Step 2 is I'm going to go ahead and switch x and y. Now step 3 is to isolate your parentheses with the y in it. So notice how I do have things outside of the parentheses. So I need to get rid of those before I can jump to my square. On this problem up here, there was nothing outside of the parentheses, but this time I do have things outside. So this is what I'm trying to isolate. So I need to get rid of the 2 and the plus 1. So going in reverse, the first thing I'm going to do is go ahead and move the 1 by subtracting it. So I have x minus 1 equals 2 parentheses y minus 4 squared. All right, I keep trying to isolate this piece right here. So I'm going to go ahead and get rid of the 2. The 2 is being multiplied. You cannot just distribute it in. When I look over here, can either of these things be evenly divided by 2? No. Yesterday, I always had you just divide each of them separately, because we're doing like slope-intercept form, y equals mx plus b. But today these are not slope-intercept form, so I can go ahead and kind of leave it as one big fraction. So my 2's are going to cancel, so I have x minus 1 over 2 equals parentheses y minus 4 squared. So again, I have a power of 2, so the way that we cancel that exponent is we take a square root of both sides. It will cancel. Since 2 is even, I have to put my plus or minus in front of my square root. So I have plus or minus the square root of x minus 1 over 2 equals y minus 4, because the square canceled. And I do have a step 5, solving for y if necessary. There was something in the parentheses with it, so I have to go ahead and move that to the other side by adding it. Y is officially by itself, so I can go back to function notation. The original problem was an f, Frank. And then since there's that plus or minus, I'm going to go ahead and put the 4 first, and then plus or minus the square root of x minus 1 over 2. And you could technically like simplify or like put it in slope-intercept form of like 1/2 x minus 1/2, but you could also leave it as just one big fraction. Okay. All right, and that's how we do our problems. Today you're gonna have a homework, it's just PDF, get a piece of paper, write out, show all of your work, and then you wanna put these notes though into your digital notebook on slide 8 and 9. So slide 8 is the first stuff, and then the last examples are slide 9. And that's it.